Hey everybody, today we're going to go over our next session. What I'm trying to do for you is have the video available Sunday night so you can spend some time looking it over, and just in case we have issues like we did last week, I should have that all taken care of, so it shouldn't be a problem. But so you can take a look at it and take some notes before we get together. That way you can ask questions if you have other things you want to share and say, hey, what about a problem like this, or how would it work that way? We can take care of those issues and spend more time communicating together rather than just listening to a lesson. That'll give me an opportunity also to go through it a little more rapidly and get to those questions. So anyway, focus of today's lesson or Monday's lesson is surface area and volume of pyramids and cones. And again, this will be available Sunday night. So make sure you take notes, get your notes out, and let's get going. Pyramids and cones. All right, our goal is to find the surface area of the rectangular pyramid and cone, and to find the volume of a rectangular pyramid and cone. And we will be looking primarily at square pyramids, but it'll work for all of them. So first of all, what do we notice? What do we wonder? We might be noticing things like, hey, there's triangles here and there's squares. Those are geometric figures. Yeah. What do we wonder? Why are these two together? Well, you may really not wonder that if you remember your geometry or the geometry stuff you talked about in middle school. This is actually called a net, and it's kind of a picture of our pyramid. And I want to show you very quickly exactly that this is exactly true. Let's take a look at this net of a square pyramid. I'm going to run this for you. Watch what happens. Each of those little triangles drop down. Oh my gosh, just like we thought. And we have our net. Okay, I'm going to make that stop so you can see that the sides of this shape, this pyramid, are triangles, and the bottom is a square. And that's exactly what we have here, showing that this two-dimensional shape, when folded and put together, will make this three-dimensional shape. Or conversely, that means in the other direction, if we were to cut along these lines and open this three-dimensional figure up, it would look like that. Okay. So parts of our pyramid, we have an apex. The apex is the top vertex where all the vertices of those triangles meet. That's called our apex. And the base is always perpendicular to the height, and the height, you can see, connects the apex perpendicularly to the base. Slant height, this might be a new term for some of you. Slant height, you might be saying, well, that's the height of the triangle. You're absolutely correct. But the triangle in this case is the slanted side of our pyramid, so we call it the slant height. And lateral surfaces are the sides. So it's the sum of the areas of the triangular sides. Those are the sides of the pyramid. So just a few new terms for you. Make sure you get those in your notes if you don't know them already. Okay, so the first thing we're going to do is find the surface area of this pyramid. So we want to remember that our pyramid is a net, has a net, and that net, I've got a little picture of it here for you, is made out of a square base and 4 triangular sides. So in our case, that base has sides, that squares has sides 11 and 11. So if this one side over here is 11, this one is 11, then the other one's going to be 11 as well. They're both 11. All right. So we have to find the area of that base. And the area of the base is, because it's a square, it's going to be 11 times 11, or 121 inches squared, because we're talking square. And then the area of the triangles, the sides, we have 4 of them, but one of them is made up of a triangle. And to find the area of a triangle, are you saying that formula that we use? It's going to be the base times height times 1/2, or divided by 2. So the base of the triangle, these triangles here, I can write those numbers in for us just so we know for sure. This triangle here, if we're looking at this one, I'll try to highlight it the best I can. That triangle has a base of 11 because that base is the side of the square. And then the height, they told us right here, is 6 inches. So the area of one triangle is 6 times 11. And then we divide that by 2 because it's 6 times 11, base times height, divided by 2, or 33 inches squared, or squared inches. Now we have 4 of them, so we need to take the 33 times 4, and that gives us 132 square inches. Okay, so now we found the area of the base. We found the area of the 4 triangles. To find the total surface area, what we have to do is add both of those up. Whoops, we have to add both of those up. And so again, we're finding the surface area of the whole figure, and that is done by combining those two values. So the surface area is going to be the 121 plus, so here's our 121 down here, plus the 132 right there. So 253 square inches. All right. So in summary, how do you find the surface area? I'm going to give you a minute to say it to yourself. Okay, not quite a minute, maybe 27 seconds. You know how I am with 27 seconds. So how do you find the surface area? For the square pyramid, it has 5 faces. One face that is the base. The base is a square, and the other 4 are the lateral sides. So that would be our triangles. We first of all, find the area of the square. Then we find the area of one of our triangles. Make sure we're using slant height, not the actual height of the figure. And if it's not given to you, you may need to use the Pythagorean theorem. We'll be doing that in just a minute. And then you multiply that area times 4, and then add your 2 areas together. The area of the base, so our blue surface, plus the area of all 4 of those green surfaces, and that's how you find the surface area. Good job. Okay. To find the volume of a square pyramid, oh my goodness, I have an awesome video to share with you that tells us or shows us how we end up getting the formula that we're going to use for this. Because sometimes it's a little bit like, really, where did that come from? And remember, volume, when we're talking about volume, people, we're talking about filling this thing up. So we're saying how much stuff would this pyramid hold if I wanted to fill it up with stuff? How much would it hold? So let's take a look at this video. I think you're gonna like it a lot. Let me get there for us. Okay, I will enlarge it. And here we go. It takes about 2 minutes. By the way, this is going to show us the volume not only of a pyramid, square-based pyramid, but it's also going to show the volume of the triangular-based pyramid and a cone. And the cool thing about this is we're doing both pyramids and cones right now. And when it comes to volume, you do both of them exactly the same way. So that's kind of nice. Let's take a look. Okay, so hopefully from watching that video, you noticed that the volume of both...
Hello everybody, Mrs. Peck here. We have made it to week 2 of distance alert.
Sorry about that. What you should have noticed is that the volume of both a pyramid and a cone is 1/3 of the volume for the pyramid would be a cube, and for the cone was a cylinder. So really, really nice to notice that the volume is easy for us. It is just simply the area of the base times the height, and then we divide that by 3. And we're going to use this same formula for both square pyramids and for the cones. So this is an easy one, hopefully, for you just to memorize. So we have a square base. Again, we're looking at the square base, and we did this before. So our square base is going to be 11 times 11, which is 121 square inches. And then the height of this thing, it's like, how do we find the height of this? Well, to find the height in this case, what we're going to have to do is do a little bit of work. And yeah, I did say work. And what we need to do is remember that we need to find the height. And the height is that distance between the vertex perpendicular to the base. So this is our height right here. I'm going to write that in with an H. And to find the height, we're going to have to use something that you all are very, very familiar with. We're going to connect this up over here and notice the shape that makes. It actually makes a right triangle. So what we have is, I think I'm going to do these in 3 different colors, hopefully to make it easier for you to see. So I'm going to do the height in pink. We'll do the base of that triangle in the green, and then I will use the red for the 6. The hypotenuse is the 6. Okay. So notice we have this right triangle here, and the hypotenuse is 6. That's our slant height of the square pyramid. The base is, what is the base here? The base of this right triangle is going to be half the length of the base itself, half the length of this, because the height is going to come right down in the center. So this is going to be 5.5. Okay, and then the height is h. That's what we're trying to find. So that's our h. Okay. So what are we going to use to find that, people? Hopefully you're all saying, Pythagorean theorem, Pythagorean theorem. Oh my gosh, we need to use the Pythagorean theorem. Yes, we do. And to use the Pythagorean theorem, we remember that 5.5 squared plus h squared is going to equal 6 squared. And we'll just highlight that up for us. So finding the height, we're going to need to use the Pythagorean theorem. So the 5.5 comes from half the base length. So this base is 11, but the center, the height is going to be coming down from the apex, which is going to be in the center there. And so that's going to be halfway. And so we take x squared, we're using x squared plus 5.5 squared equals 6 squared. And our x squared plus 30.25, that is 5.5 squared, equals 36, which is 6 squared. So x squared is going to equal 5.75. And x, or the height, you can call this h, is going to equal 2.4 inches. Okay, so that gives us the height, and we can then go back and say, okay, I'm going to change this. It's not h anymore, or height. It has a value, and that value is 2.4. So we can put in 2.4. Then how do we find the volume? Because that is still what we're looking for. And the volume, as we said before, is found by taking the area of the base, which we have, 121 square inches, times the height, which we now have is 2.4 inches. So we can multiply those two together from there. It's really, really easy. And if you have a problem where they give you the height, it's a whole lot easier to do. But you may have to compute it. So the volume is 121 times 2.4, and then divided by 3. So you multiply these two numbers together and divide by 3. The answer is 96.8 inches cubed, because now we're filling it up. We're going 3-dimensional, and so we're doing cubic inches. Okay, so next we're going to look at, again, summarizing what we need to do to find the volume. Give you 27 seconds. Review. And to find the volume, we may need to, if you're not given the height, just a reminder, you may need to use the Pythagorean theorem. So to find the volume of a pyramid, if you don't have the height, use the Pythagorean theorem to find it. Then you find the area of the base, and then multiply the area of the base times the height, and then divide by 3. I guess I didn't put the formula up there. Let me do that real quick. So again, the area for the formula for volume equals big B, which is area of the base, times height, and that's height of the figure, and then we divide by 3. Very good. Okay, next we're going to take a look at cones. What do you notice and what do you wonder? All right, here we have, the cone with the round bottom, round base. We have a funny looking flat thing with a circle here and another part of a circle, kind of, yeah? Or it looks kind of like a triangle. Yeah. So this is actually the net for the cone. And again, I want to go back and share that with you, because this one is really also very neat looking. Hold on just a second. The net of a cone. And take a look at this one. Whoops, I didn't want to show you that just yet. Hold on. So the net, watch this. It's so fun. Isn't that neat? So you can see how this cone, they're two exactly the same cone. They just copied that over and then opened it up, and you can see how that slant height opens up to become the base of this shape. Is that just the neatest thing? And I'll have it go backwards again. This is fun. And back we go, slant height. And then it closes up. Oops. There. So the formulas we use for surface area of a cone are right here. I'd like you to copy those down. It's actually the same formula. Big B, as I shared before, the big B is just the symbol that we use, the letter we use to represent the area of the base. So in this case, the surface, we're going to find the area, surface area, by taking the area of the lateral area, and you do that using slant height times radius times pi. And this L, cursive L, is the letter we use for slant height, just so you know that. So it's pi times r times slant height, r the radius, plus pi r squared. Okay, let's get back to our presentation here. And I should have told you the parts of the cone are very similar to the parts of a pyramid. We have an apex, we have a height, we have the base. Our base, though, is a circle this time. There is the lateral surface, which is, again, the sides, and then the slant height. So we have the same exact surfaces. They're just figured a little bit differently because it's a round base rather than a rectangular base or a triangular base, but very, very similarly. So to find the surface area of a cone, the first thing we're going to do is to find the area of the base. Okay, so to find the area of the base, we're going to use pi r squared. So we do pi r squared. This part should not be new to you. You've been finding area of a circle for a long time. You should know this formula. Because we have the diameter here, 18 centimeters, we have to remember a radius is half of a diameter. So for this case, we're going to take 9 squared times pi, or 81 pi, again, centimeters square. For surface area, it's we're finding the area of this thing. If we opened it up, we're finding the area of the net is basically what we're doing. And then the lateral area, again, is found by taking half the circumference times the slant height, okay? Half the circumference. So the circumference, again, is 2 pi r, but we want half of that. So we're doing half of the circumference times the slant height. And so in this case, that's going to give us our circumference is, excuse me, is 1/2 times the diameter. It's r. 2 pi r. Okay, so what we want half of that. So we're going to take 1/2 times 18 pi times 20.1. We get 180.9 pi. Or we rounded this up, chose to round this up to 181. Okay, so to find the surface area, you would add those two together. And, whoops, I missed my number. Okay, so when we add those two together, I'll just write it in because my value is missing. So we're going to add up then 81 plus 181. And if I've added this correctly, we should get 262 square centimeters, or centimeters squared. All right. So in summary, what do we do? What are the steps we use to find the surface area of a cone? Okay, again, to find the surface area of a cone, we are going to find the area of the base. In this case, again, that base is a circle, and we use the formula pi r squared. To find this lateral area, this part up here is our lateral surface area, by using the general idea of a triangle, which is 1/2 base height, but the base is the circumference of a circle, which is 2 pi r. Okay, so we're really looking at this. This is where the 1/2 comes from, is it's 1/2 base times height, but the height is going to be 2 pi r, and that's our slant height, and the height is our slant height. So the lateral surface area is 1/2 diameter pi times slant height. Okay. All right, so to find the volume of a cone, as I shared before, the volume of a cone is the same formula, same thinking process as the volume of a pyramid, because they really are basically the same figure. It's just that the base is slightly different. One's round and one's any number of other shapes. So we use the same formula, but we may have to many times, again, use our Pythagorean theorem. So I've got that up for us again in the corner. In this case, we were not given the height. So just like with the pyramid before, we're going to use our slant height, and we're going to use, in this case, not the radius, because radius is going to be half of the diameter. And we notice that this again forms a right triangle. So we have a squared plus b squared equals c squared, where 9 is your a, the h is our b, and then our 20.1 is the c, which is the hypotenuse. So we add those values together. 9 squared is 81. 20.1 squared is 404.01. We're going to subtract the 81 so that we simplify the equation, get h squared equals 323.01. and then find the square root of both sides. We get h equals 17.972 or 18. We're going to round it to make the numbers easier for us to work with. But that gets us the height. So now we know the height of this thing. And I can once again write that in. So this is going to be 18. And we can now find the volume by using our formula. Remember the formula? Volume equals big B times H divided by 3. Yeah, the volume is the area of the base, in this case a circle, times the height, which we just figured out to be 18, and then divide that number by 3. So this is what it looks like. The base, again, is a circle, so the area is pi r squared. Pi times 9 squared is going to be 81 pi. Then we're going to take that 81 pi times the height of 18, divide it by 3. That gives us 486 pi. And what did I forget to put on there this time? We don't have the units, but we remember from last time that it was centimeters. So I'm going to go ahead and write in the centimeters cubed. Because on your quizzes, or not the quizzes, on the online activities that I had you guys do, that was something that I didn't really take off for if you had the right answer, but you forgot to put down your centimeters squared or centimeters cubed. Please know I didn't take off for that, but it is a kind of a big deal. And at this point, it's just a matter of reminding you. If we were taking a big test on this, that would matter. So please pay attention to your units, okay? Now, in summary, excuse me, how do we find the volume for our cone? Okay, first things first. If we have to, we use the Pythagorean theorem to find the height. If they didn't give us the height, we got to find it. And we can do that. So we use Pythagorean theorem, we use our slant height, we use our radius, and we find the height of our figure. Once we know the height, it's the same thing as a pyramid or any other figure in this shape. We're going to go ahead and say our volume is found by finding the area of the base, knowing that we can do the area of the base times the height. But because this thing is 1/3 of a cylinder, we have to divide it by 3. Okay, and that's it. All right. So the next two problems I have for you, I'm just going to share them with you. They're practice problems. I'm not going to work them out on the video, but I will work them out with you in class on Monday. So until we meet, try working these out yourself, and then we can talk about them. That'll be kind of a fun thing to do. So here's the first one. Find surface area and volume of this pyramid. I know you can do it. And the second one is find the surface area and volume of this cone. Okay, well, you guys enjoy the video. Again, go back through it if you have to. Take notes and make sure that you're ready to ask questions on Monday. And make sure you have these two practice problems done so we can talk about it. Until then, have a great weekend, and I'll be talking to you soon. Bye-bye.